Welcome to Industrial PLC Applications. This video is in preparation for Lab 1, the Bulk Hopper and Conveyor System Order of Operation. Many companies have conveyors that are connected to other processes. When it comes to moving certain products like aggregates, a hopper controls the amount of material being placed on the conveyor. The hopper cannot open unless the conveyor is already moving. If material is placed on the conveyor before the conveyor starts, the material will likely stall the motor and damage either the conveyor or the motor from overheating, etc. By having the conveyor running first, the material spreads along the conveyor when it runs. At the same time, you do not want to leave material on the conveyor when production stops. So it's important that during a normal operation shutdown, the conveyor should run for a period to clear the conveyor of material. There may be a small amount of stray material left on even after the rundown. Therefore, you want to warn people that material may fly off the conveyor, so keep clear. A pre-start warning horn is often installed for this purpose. Lastly, the vessel receiving the material must be in place to receive it. Therefore, if there is no vessel, no drum or truck, etc., then the hopper must close and the conveyor must stop. So this is a representation of the system as it would be in an as-found condition at the start of the day, all stopped. The disconnect switch would be off, the stop-start push buttons would be off, the E-stop is likely pressed, the start push button is off, the stop push button may be pressed, the hopper should be closed, and the hopper solenoid should be turned off. This being a spring return, when the solenoid is de-energized, the hopper gate will automatically close by the re-expansion of the spring. The proximity switch for the prox may or may not be present, depending on whether there was a drum left in that position. As part of the startup routine, of course, the disconnecting means is going to be turned on. There's a stop and a start push button. One of them will need to be pressed to start the whole system, but at least the main disconnecting means has been turned on. So before the start push button is pressed, we make sure there's a drum in place. We make sure that the E-stop switch is reset and the stop push button is reset. And then we press the start button. The start push button is pressed. It's momentary, so you can release it. But as it turns on, it's going to set the MCR to the on position, pulling in. And that's going to start a horn which will sound for a few seconds and then stop. Once the horn shuts off, the motor contactor pulls in and the motor starts to build up speed. As the motor is building up speed, the proximity switch that's looking for the drum confirms that there's a drum present. In a few seconds, the motor will reach full speed. The drum has been confirmed, so at that point the hopper solenoid is activated. It pulls in the cylinder and the hopper is open. The drum begins to fill and it takes about 15 seconds. When the drum is full, the hopper solenoid is shut off and it closes the hopper. The drum swap out, the motor is allowed to coast. In other words, they take power away from the motor and its inertia will continue to run, waiting for the next drum. Once the drum presence has been detected, the motor is turned on again. Having both the motor running and the drum present, the hopper then opens and begins to fill the drum. And this system continues to repeat for every single drum filling. If the stop button is pressed, the system will continue to fill the last drum. When the last drum is full, the system stops. This is not to say that it has been completely disconnected. It just means that the motor shuts down and it's ready to be started again by hitting the start button. However, at any time, if the E-stop push button is pressed, everything stops where it is as is. Although with no brake, the conveyor may coast as before.